Greetings and welcome, or welcome back as the case may be. Today I thought I'd post a little video about continuing with my discussion of the various types of telescopes. And so today I thought I would discuss X-ray telescopes. Don't hear a lot in the common media about X-ray telescopes. So there's a few things to point out and go over. First, starting with the atmosphere of the situation in and of itself. X-ray telescopes are a fairly new thing for the simple reason, if nothing else, they've got to be in space. Our 90 kilometers of atmosphere are opaque, thanks to the ozone layer and so forth, to X-rays. In other words, X-rays don't penetrate to the ground, period. So to get an X-ray telescope to work, you've got to have it in space. In fact, a lot of telescopes only work in space. I often pose to students, what color is the atmosphere really? And the answer is black. It is opaque to all but a few small windows until you get out into the radio wavelengths, microwave and radio. It is opaque. It is black. It absorbs all but this tiny little window, which happens to be what our eyes detect. So the overall color of the sky is actually black. There's something for you to think about. So how do X-ray telescopes work? Because X-rays, don't they pass through pretty much anything? And the answer is yes. And the answer to how they work, how they focus X-ray light to a point, to a focal point, is that they use a completely different principle than a lens focusing or a mirror reflecting. Because, yes, the X-rays, if they hit a mirror bluntly, a very perpendicular, if you will, pass right through it. But we use this idea that we call glancing incidence. It's much like skipping a rock across the surface of water. And X-rays will, if they come in at a steep enough angle to the surface, will skip along. It looks something like this. This is a diagram that I got from the Chandra X-ray telescopes website. And you can see how its mirrors are set up. There's paraboloid surfaces that focus the light through glancing incidence. They come in at very shallow angles, glance off of one parabolic mirror, hit similarly a hyperbolic mirror, and that focuses it to a point, or rather to a plane, as we've kind of discussed before, because the sky is a two-dimensional grid. So that's a plane. So this is how we focus X-ray light so that we can make pictures out of it, images. So why might we like X-rays? Well, one is there's a lot of high energy phenomena going on out in the universe. And high energies mean X-rays. Neat. The other thing is kind of something I've mentioned in passing. The resolution, the angle, the how fine a detail you can see scales as the wavelength. Or the inverse of the wavelength, I should say. So the shorter wavelength of light you use, like X-rays over visible, the finer details you can see. Now, because we have to use, there's some limit to that due to the fact that we have to use glancing incidence and have to have the telescope in space. So there's only so large a mirror, or set of mirrors, I guess I should say, that we can use for an X-ray telescope. So these are things that limit it, and this is why we like using X-rays and why we go to the trouble, because they show us the universe in finer detail, and they show us things like hot ionized gas between galaxies in galaxy clusters. And so we can see where a lot more of the regular matter is in things than when we use optical wavelengths. So it gives us another window on the universe. And with that, I'm going to call it a post. I'm going to call it a video. And we'll see you next time, where we'll be talking about microwave and radio telescopes. So until then, have a good day. Bye.